All right, so we're going to talk about the polarity of bonds. So remember, you can have polar or nonpolar covalent bonds. And so polar and nonpolar covalent bonds are a type of covalent bond. So they're still sharing electrons. But here, nonpolar covalent bonds means they share electrons equally, whereas polar covalent bonds share unequally. But one of the keys you want to remember is that nonpolar and polar are still covalent, meaning they're still sharing. So polar and nonpolar are a type of covalent bond. And then we learned ionic bonds. And so the way we know if it's nonpolar or polar is we look at the electronegativity between the two atoms that are bonded together. So let's do some examples. So let's take the example of oxygen and fluorine. So if we look here, oxygen is 3.5 and fluorine is 4.0. So the difference is 0.5. So here it's 0.5. And then if we go back and look, we would notice that 0.5, the difference in electronegativity falls within the polar covalent bond. And so oxygen and fluorine, this bond is polar, which means they're sharing the electrons in this bond, but they're not sharing equally. Fluorine is stronger, so the electrons are moving towards fluorine. Here we have a diatomic molecule, chlorine and chlorine. So if you think about it, chlorine and chlorine should have equal strength or equal electronegativity. So if you look, chlorine is 3.0, so it's going to have a difference of 0. Anything with a difference of 0 is going to be nonpolar. So between chlorine and chlorine, the difference is 0. They're sharing it equally. If we look at cesium, which is way over here in chlorine, what you'll notice is the difference is going to be quite a bit. We know this is ionic for two reasons. One, the difference is going to be 2.3. Here it's going to be 2.3, so that's going to be ionic. The second reason is we have a metal with a non-metal, and that's ionic as well. And then sulfur and oxygen, so sulfur and oxygen is 2.5 and 3.5, and so that is 1.0. Anything between 0.3 and 1.7 is polar covalent. Okay. All right. So we just talked about bond polarity. So molecules themselves, molecules which are the compounds themselves, have their own polarity. And so the rules go by, if it's a polar molecule, if you have one or less line of symmetry. And then it's a nonpolar molecule if there's two or more lines of symmetry. Okay? And so we just want to get that idea. So there's a bond. So let me just kind of give you an example. So let's say we have, let's take an example of NH3. And so we'll learn how to do this, but NH3 looks like this, all right? And so what we're looking for is a line to symmetry, which means if I put a line through this, either side will look the same. So we do have one line of symmetry, and if you look, the line of symmetry is right here, right? So this side, both sides look the same, right? They're mirror images of each other. But if you look, I don't see another line of symmetry. Like if I would like this, is this? No. Right? There's no line, there's no second line. So this is what we call a polar molecule. What we just learned was that I could ask you, okay, what's the bond polarity? What is the bond polarity between nitrogen and hydrogen? We would go back, take a look, and you would find that nitrogen and hydrogen, that's also a polar bond. So I just want to show you that there's two types of polarities. One of the whole molecule, and if you want to find the polarity of the whole molecule, you have to take a look at the lines of symmetry. All right, so, and then the polar bond, that's when you do the subtraction, the difference of electronegativity. So there's two types of things we're looking at here. So we've learned about polar bonds, or the polarity of bonds, and then we're also looking at the polarity of molecules. All right. So how do we know about these lines? Like, how do we know what happens with the bonds, that kind of stuff. How do we build the molecule? So first of all, let's go and translate this into a formula. So this is carbon tetrachloride, so CCl4. All right, so usually the first element is the central atom. It's the atom everything builds off of. And so what I would suggest you do is you would put it and then you draw the Lewis dot. So 1, 2, 3, 4. Carbon has 4 valence electrons. Okay, and then there's the next they're the ones that are going to be around carbon, because carbon's what we call your central atom. So there's going to be chlorines around. I'm going to draw it like this, and I draw it like this for a particular reason. You'll see. So I'm going to draw 1, 2, 3, 4, 5, 6, 7. All right. So before I continue, we know this is a covalent bond. The reason why is carbon is a nonmetal and chlorine is a nonmetal. Now, if we put them together, what we'll notice is carbon, this chlorine, requires another electron. But carbon doesn't want to give up its electron. So what they do is, in covalent bond, they share. And so what happens is carbon says, I'll share this electron with you. And chlorine says, I'll share this electron with you. And so this satisfies chlorine's desire to have 8 valence electrons, which makes it stable. Right. So chlorine has 2, 4, 6, 8. Now this other chlorine does the same thing. It says, okay, I'm going to share this electron with you. So now it has 8. 8. And remember, the goal in the end is always to get 8, right? So 8. Now what about this carbon? Well, this carbon actually has 8. If you look at it, after bonding 4 times, it has 8, right? There's 1, 2, 3, 4, 5, 6, 7, 8. Okay? Now, you can imagine drawing this is kind of crazy, right? Like, this would get kind of hectic. So, you'll see that there are, and I'll do this in green, these are shared electrons, right? And so instead of drawing 2 dots for the shared pair of electrons, what we do is we draw lines, kind of like we saw. So, what this will translate into, and I kind of did it a little big, but what it'll translate into is carbon with chlorine on each side, like this. If you want to put the rest of the valence electrons on chlorine, that's cool, but it looks like this. So what is the bond polarity? Well, if you look at the bond polarity between carbon and chlorine, you'll know that this is actually a polar bond. This is a polar bond. But what about the molecule polarity? Well, the molecule polarity is a little different. Because what you'll notice is there's actually a lot of lines of symmetry. Like, here's a line of symmetry, like both sides, but here's a line of symmetry, right? Here's another line of symmetry. There's a lot of lines of symmetry. So if you have more than one line of symmetry, it's going to be nonpolar. The molecule is nonpolar. So the bond is polar, but the molecule, or the whole compound itself, it's nonpolar because there's more than one line of symmetry, right? Okay. All right, so let's try some more examples. So silicon dioxide. So what does silicon dioxide look like? So let's do it. So silicon has 4 valence electrons. Here we go. 1, 2, 3, 4, and then 2 oxygen dioxide. So there's going to be an oxygen here and an oxygen here. 1, 2. Oxygen has 6 valence electrons. So this actually is going to be a little tricky. Let's do. Okay, so let's say this silicon says we're going to share an electron. So oxygen wants to get to 8. So this silicon puts that here. We'll take 1 oxygen here. Okay. Now, what does that give oxygen? That gives it 1, 2, 3, 4, 5, 6, 7. Not enough. So oxygen says, hey, I'll share another electron with you. So I'll take this electron. Let's take this one here, and we'll move it over here. And this silicon says, okay, I'll share a second electron with you. So I'll take this one from the top here, and I'll move it over here. So now oxygen has 8, 2, 4, 6, 8. This oxygen is going to do the same thing. So it's going to have 4, but then it's going to share 2. So 1, 2, and then silicon is going to share 2 as well. All right. So what happens is now oxygen has is 8, silicon. Now, what do you notice? They're sharing 2 pairs of electrons. So how many lines are we going to draw? Well, we're going to draw 2 lines. This is what's called a double bond. So this is what it looks like. Okay. All right. Now, what kind of polarity does this molecule have? Well, it has at least 2 lines of symmetry, if not more. So that gives it, the molecule is nonpolar. Okay. And the last one is water, dihydrogen monoxide. Now this is weird because there's 2 hydrogens and 1 oxygen, but actually the central atom is oxygen. And I don't know why they do it this way, but so we have oxygen, we have 1, 2, 3, 4, 5, 6, right? And then hydrogen. So there's a hydrogen here and a hydrogen here. All right. So hydrogen has 1 valence electron. Now in order to be full, hydrogen needs 2. So once again, both hydrogens, what they'll do is they'll move their electron closer. Oxygen will move, let's just take from here, like this. So now oxygen has 8, here's the 8, and then hydrogen has 2. Okay? So what it looks like is oxygen will have 1, 2, 3, 4, and then a hydrogen like that. Okay, that's what water looks like. Now, there's definitely 1 line of symmetry here, but there's not another line of symmetry here if you look at that, right? And so there's only 1 line of symmetry, so actually this is a polar molecule. And then if you look at the bond, the hydrogen and oxygen, this is a polar bond as well.